Welcome back, IGCSE team. Today we're going to talk about the general equation of a straight line. Now, for most of you, I believe this will be a review. The general equation is like this. Y is equal to m multiplied by x plus c. Y equals mx plus c. Now, we've got to do some definitions here. We'll start over here. This is the y-intercept, which means the point at which the line crosses your y-axis. This bit is your gradient. Your gradient is to do with how steep your line is. This is just an x coordinate. Now, when you know your gradient, you multiply it by an x coordinate and you add the y-intercept, you're going to get your y coordinate. So it's just a function. So this is one way of arranging a line. Notice that the x is to the power of 1. That's why we've got a straight line. If we had x to the power of 2, we'd have a quadratic function, and you know that a quadratic looks like this or it looks like this. So and if we had, say, an x to the power of 3, we'd have a cubic which might look something like this, or perhaps even something like this. Okay, so depending on the power that you have will depend on what kind of function you're graphing, but when it's just to the power of 1 like this, it's going to be a straight line. Now let's have a quick look. Let's say I had something like y equals 3x plus 2. This would be my y-intercept, and this 3 would be my gradient. In other words, if I was to sketch it, I know that it would cross my y-axis here. And I know that every time I go across 1 unit, I'm going to go up 3 units. That's what a gradient of 3 means. So I would be, once I'd have a coordinate at 0, 2 and 1, 5. And so that would be quite a steep sort of line. That would be y equals 3x plus 2. Let's say I had another line, maybe y equals 3 plus 2x. Now be careful, sometimes things are switched around. This case, my y-intercept is 3. Okay, it's the term that doesn't have the x. So I'm going to be crossing there at 3. And this here, this 2, tells me that I go across 1 and up 2. So it will also have a point at 1, 5, but you'll notice that it's not as steep a line as the 3x plus 2 line. Okay, let's just clear that space and try a couple more just to give you an idea of how this works. Let's say I've got another coordinate plane here, and let's say I have to graph maybe 2y equals 3x plus 4. Now I would have to rewrite this by dividing both sides by 2 so that I've got a y equals mx plus c. I can't have a 2y, so I'm dividing everything by 2. Thus my 3 becomes 3 over 2x, and my 4 becomes 4 over 2. Right, 4 divided by 2, and we could just rewrite that as 2. So now I know that my intercept is at 2. And what do we make of this gradient here? Well, the bottom one is your across, and the top one is your up. So change in y over change in x. So we go across 2, so I might go 1, 2. So this will be at 2, and then we'd go up 3. So this would be 5. So if we're going to cross at 2. Then by the time we get to 2, we've gone up 3. So this would be a gradient of 1.5. So every 2 squares you're going to go up 3, which makes sense, right? 1.5 times 2 is 3. So that would be this one. Y equals 3 over 2 x plus 2. Let me give you another example similar to this. I'll just clear all of this. Let's say we had something like 4x minus 2y minus 3, and I wanted to know the gradient. Well, again, I need to change how this looks. Oh, sorry, I should have an equals there. So my first step is I'm going to pull my 2y across to the other side. Then I'm going to rewrite that so that my y is first. Then I'm going to move my 3 across by subtracting it from both sides. Then I'm going to divide everything by 2. So 4 divided by 2 will be 2x minus, and then I have minus 3 over 2. So this is similar to the previous one we've got, but we've just done a bit of a change. We are crossing at negative 1.5 or negative 3 over 2. That's our y-intercept. That's this bit here, y-intercept. This is our gradient. So as we go across 1, we go up 2. So that will mean our next point will be at 1, 0.5. Okay, ooh, there's my line there. Okay, it'll go like that. So gradient is 2, and y-intercept is negative 1.5 or negative 3 over 2. So that's just a bit of a feel for how you do the general equation of a straight line and how you rearrange a formula if it's not in that general equation. Now the next thing I'm going to do is I'm going to have a look at this, these 3 graphs to the right. So we'll start, 4 of them, sorry. I'm going to start off with A. Now let's look at the gradient. The way to do a gradient, well, we've got an intercept here, don't we? Okay, that looks like y-intercept at 3. And the gradient, let's have a look at the gradient. Every time we go across 1, oh, that's not very good because it's sort of halfway. Let's go across 2. So every time we go across 2, we go up 3. So the gradient must be change in y, 3, over change in x, 2. So we'd write this as y equals 3 over 2, that's our gradient, that's the m part, 3 over 2 x plus 3. The 3 is our y-intercept. Now, let's take a look at B, that purpley kind of coloured one. Okay, B. Now, B has an y-intercept of, that looks like a 4, doesn't it? At 4. Let's have a look at the gradient now. Now, I can see that we're going, here we go. I'm going to go across 4. I'm going to go down 1 and across 4. There's my triangle there. Down 1, across 4. So the gradient is negative 1/4. That means every time you go across 1, you go down 1/4, or every time you go across 4, you go down 1. So that's the gradient. So therefore we say y is equal to negative 1/4 x plus 4. This is our gradient, oh, not the x, the negative 1/4, and this is our intercept. Now let's have a look at C. Here's C. My y-intercept looks to be at negative 1, and my gradient, let's have a look at the gradient. It's a positive gradient. I go across 2 and up 1. So change in y goes up 1 over change in x, 2. So a gradient of 1/2, we'd write this as y is equal to 1/2 x minus 1. 1/2 being the gradient and minus 1 being the intercept. The last one is this orangey sort of thing. Yes. We'll try this. So D, maybe I'll just write that up here, D. We've got an intercept there of 5, so y intercept is 5. Gradient is a negative gradient. We go across, I'm going to use this triangle here. I'm going to go across 3, and I'm going to go down 5. So the change in y is negative 5, and the change in x is we've gone across 3, so down 5 across 3, so that's our gradient. So we'd write that as y is equal to negative 5/3 x plus 5. So that's how you can just change what you see in as a line. You can derive the general equation of that straight line just by looking at the intercept and the gradient. Now we're going to go down a little bit further. We've got a few more things to do before we call it quits. Okay, I've got to write down some equations of some lines here. So I'm going to try line C. I know that the gradient is equal to 3, and it passes through 0, 2. Now, if I were to draw this, 0, minus 2 is here. So I know that that is actually, that's my y-intercept. Okay? So I could write this line for C as y is equal to 3x minus 2. This is my y-intercept. That's the x value of a y-intercept. X is 0 when we have a y-intercept. Now, let's take a look at this one here. This is a little bit harder. First of all, we learn it's parallel to y minus x equals 6. Now, I'm going to rearrange my formula to say 2y equals x. I'm going to add x to both sides. Then I'm going to go y is equal to 1/2. I'm dividing both sides by 2. And now I know that my gradient is 1/2. Okay? Now, the problem is you can't go and go, oh, I know, the gradient, the intercept must be 3. No. We know that our line is parallel to that line, but it is not the same as that line. So far I've got this. Y is equal to 1/2 x plus c. And I don't know c, and I don't know x or y. Or do I? Well, actually I do. I know that these are x and y values for my line. So I'm going to chuck them in. 1 is my y value. My x value is minus 6. And this must be true if it is on the line, which it is. So 1 is equal to, what's half of minus 6? That's minus 3 plus c. Therefore, c must be 4. So we can now write our equation. Y is equal to 1/2 x plus 4. Okay, a couple more things that we'll do. We're going to sketch some graphs. I'm going to talk to you about the 2-point plotting method. So this is a nice quick way of plotting graphs when they're not in the form of y equals mx plus c, but they're in another form. So here it is. Let's say we've got 5f's an example of this, right? 5f. I've been asked to sketch 2x plus 3y equals 12. Okay, so it's my y-axis, my x-axis. Now, key idea for the 2-point plotting method is that x is equal to 0 along the y-axis, right? And along the x-axis, this way, we know that y equals 0. So we can find those 2 points. If x is 0, we'd have 2 times 0 plus 3y equals 12, and therefore 3y equals 12, and therefore y equals 4. So we know that we've got a crossing point of 4 on that axis. Now, we could now go and find what we get when y is 0, i.e. on the x-axis. So 2x is equal to 12, so x is equal to 6. So we've got our other point here. Let's say this is 6, and then we just draw a line connecting those 2 points. And that would be our 2x plus 3y equals 12 sketch. Okay, that's all you need to do. Find those 2 points. I'll do one more example. This is not a 2-point plotting example. This is just doing a quick sketch. I need to apparently sketch, this is 5g, 2x minus y equals 3. Well, I'm going to go and change my equation to this, and then I'm going to write it so that y is at the front. Then I'm going to get the y by itself by subtracting 3. And now you see that I have a y equals mx plus c. And here's my y. Of course you can do this neater in your book. Here's my y-axis, here's my x-axis. I know that I have negative 3 here. And I know my gradient is 2. And what do I have when x is 1? Let's call this 1 here. 2 times 1, so I'm going to have minus 1. So I'm going to be somewhere here. Okay, and it's going to cross. So when I get to 2, I'm going to be up at 1 here. So something like that. I've not drawn it very accurately. But there is my graph. Okay, so this is y equals 2x minus 3. And another way you can do these is drawing using your table mode on your calculator, but it's best to be able to do what I've been doing. All right. Well, I hope that helps you make a start on exercise 2.10. All the best. Let me know if you have any problems.